The electrical installation quality is confirmed by testing. As radio and antenna systems become ever more complex, it's impossible to cover every test in every type of radio system. Instead, let us take a look at some basic testing principles. Radio base stations undergo extensive testing in the factory. Each individual module is thoroughly tested before they are installed in a radio cabinet. Equipment is tested immediately prior to shipment so that it will always work as soon as it is switched on. Antenna systems, however, are constructed on site, so system tests in a workshop or factory environment they're just not possible. RBS testing is therefore a simple verification that nothing has happened in transit since leaving the Ericsson factory. The bulk of antenna system assembly takes place up in the air, on a tower, on a wall or a roof. Installers therefore must take responsibility for assembly, installation quality and even testing. In most cases, the radio installer will do the testing, but this may require the cooperation of the antenna installer. If we take a quick look at common antenna installation faults, we see that it was only a few years ago the most common fault area was earthing or grounding, as found by quality inspectors. But later, that same year, the Grounding Guidelines Manual was actively distributed and made available to installers. As a result, just over half a year later, the earthing problems fell dramatically. They fell from first place down to third place. In a simple transmitter feeder antenna system, the installer can use the r1a Site Master or the Tektronix Y400 to analyze the feeder and antenna operation. In the event of the fault, these instruments can display the distance to the fault. The tester can even identify the microscopic signal reflections from connectors, bends and joints. We have created a multimedia course for operating the r1a Site Master. If a tower-mounted amplifier or some other similar device is fitted between the feeder and the antenna, then test instruments cannot propagate a test signal backwards through the amplifier. The antenna installer may need to uncouple the device and temporarily connect the feeder directly to the antenna. It is for this reason that tests must be completed before joints and connections are weatherproofed. So now I'm going to give you a little bit of an introduction on a possible method of testing the ASC. I said earlier on in the testing section that you couldn't do any sort of verification tests on an ASC or a TMA because you can't propagate a signal backwards through the receiver distribution amplifier. But we can actually do some sort of verification tests. I said earlier also that the ASC has got an inbuilt microprocessor. Well, we can actually make contact with that processor and, well, ask it a few simple questions. And this would normally be done after the system has been installed, but before all the connections have been sealed. And this sort of test would normally be done by the advanced antenna system installer or a qualified verification engineer. What he basically uses is an ordinary laptop PC computer, and the COM port of the PC computer is connected to a special unit here, which is a field test unit or an FTU. The FTU also receives power from a main supply, and then the output of this, the RF connector, can be connected to the feeder system and off up to the ASC up the tower. Of course, it must be connected to branch A. As I said, DC power and communication with the processor occurs via branch A, not branch B. What the software does, it interrogates the processor and it looks at the initial factory calibration table contained inside the unit, and this we can examine and see if anything has changed. The field test unit has also got support for the remote electrical tilt unit, the RET. And so we can actually do quite a comprehensive verification tests using the field test unit along with the PC. If you wish to know more about it, there is a document on how to use the instrument, and the results of the instrument on the PC are in the form of a graph, a calibration parameters table, where you can look at time delay, insertion loss, and we can see these calibration graphs and even log files for both the A and the B branches in the ASC. So we really can do some tests on an ASC using a field test unit. Radio base stations and antenna systems require very accurate feeder and cable lengths and losses to be recorded. This information is needed to set up and adjust the radio system. When the antenna system has been tested, then it is time to seal all the joints, and this must be done with care, as you will see in our next video sequence.